Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, my dear students. We ended part 2 of chapter 4 by this mentioning this example, and I mentioned that this is a very good example because it merge or it basically join the two concepts of equations of motion. The first equation of motion, which we all know from chapter 3 and 2, and this Newton's second law of motion. So basically the idea is to find the acceleration using the equations of motion and then apply it in Newton's second law of motion to find the force acting or is required for this car. I would like you to go through that one, and hopefully you will get it. Otherwise we can go through that again, inshallah. Now, Newton's third law of motion. It is section 4.5. I will just go for screening because hopefully this will be the last record for introducing the chapter. We sent already 15 minutes, that is half an hour, and this is another 15, that will be 45 minutes, and that will be really a full lecture which we are used to as a full introduction for the chapter. And as usual, I mentioned to you guys that every time you go through screening of your chapter, you go and you see the name of the section, for example. So he's talking about Newton's third law of motion, which, as we mentioned in the first part of these records, it was the action and reaction. It's a bit tricky, the action and reaction, but we need to see what are the tricky parts about it. All right, we can see a hammer. This is one of the very famous example about Newton's third law of motion. And if you also recall, there is an opening chapter problem. If you go back up to the first page of this chapter, there is an opening chapter problem that if a heavy person pushed a lighter person, you can go and refer to that problem now after finishing this section. After finishing studying section 4.5, you can go back and read the opening chapter question about the two players. One is heavy, one is lighter. And you can try to answer that from the point that you got from action and reaction law of motion. Okay. Now, one very interesting point about the action and reaction or the Newton's third law of motion is that the action and reaction forces act on different objects. This is very important. And let me emphasize what is the important about it, that it is acting, the forces are acting on different objects. So the action and reaction, they are not acting on the same body. They are acting on different objects. For example, this is a hammer and this is a nail. There is a force from the hammer on the nail, and that is the action, and the reaction is from the nail on the hammer. So again, it is the force that the hammer is applying on the nail, and there is a force as a reaction the nail is applying on the hammer. Okay, that will help us to understand later some question that which is bigger. Is it the force that the hammer is applying on the nail or the force that the nail is applying on the hammer? Are they equal or are they different? That is the main concept behind understanding Newton's third law of motion. Again, keeping in mind that they are acting on different objects. So in the first force, hammer acting on nail. So it's acting on nail. The other force, nail, acting on hammer. So the other force is acting on hammer. All right? Keep this in mind. Again, now this is how we will say the Newton's third law of motion. Whenever one object exerts a force on a second object, the second object exerts an equal force in the opposite direction on the first. Okay, so now we answer the question that if the hammer is acting on the nail will act on the hammer with an exactly equal amount of force, but in opposite direction. So don't be confused and say that the force acted on the nail by the hammer is more, because of course the hammer is heavier, stronger, everything. That is not right. The force that is as a reaction, it is created in the nail against the hammer will be exactly the same as the force acted by the hammer on the nail, but in opposite direction. Okay, so in other words, we say to every action, there is an equal and opposite reaction in simple. So this is Newton's third law in more simple ways, or in more simple words. To every action, there's an equal and opposite reaction. All right, acting on different objects. The action and reaction, they are acting on different objects. You can see those pictures, and in each one of them, you can realize that there is a force on one thing. So this is the force on the skater, and there is a force from a skater on the wall, and as a reaction, there is a force from wall on a skater. And the same thing here. You can read the explanations here. All right. And even also the third very nice example, which is also the opening chapter picture. This is the explanation of the opening chapter picture as action and reaction. And we need to know that where is the action and what is the reaction of that. And this is all explained in the caption of the figure. Okay, these are all conceptual questions that you can address, read them, and try to understand them. They are really explained so well. This is also another interesting example that when we are walking, there is a force exerted by the person on the ground. As a reaction, there is a force exerted on the person by the ground. Okay, did I say that right? So there is a force acted on the ground by a person. As a reaction, there is a force on the person by the ground. And that's what makes us walking, basically. That you push the earth or the ground with your foot. So this is the force from you on the ground. And as a reaction, the ground will push you back. So you can see sometimes you can walk slowly, sometimes you can walk faster. And this is the main explanation. Because you decide to walk faster, you start pushing the ground faster or stronger, basically. So you start walking faster. Great. So we can say that the force from the ground on the person is equal force of the person on the ground, but opposite in direction. Of course, this is in more and more and more details. Here he's explaining the same thing by the ground and the person. And here between the person and the sled, here between the sled and the ground. So we can see that so many forces are there, but each one of them is between the object and the ground, the person and the ground, the person and the object. So you can see these ones as action and reaction. And this is the same actually explanation for the person here in this picture. Okay. This also, this is, as I mentioned, this is introduction for the chapter. It requires a lot of reading from your side. So again, this is conceptual example. I expect you to go through it and understand what is going on. And if you can see here, they say in exercise B, C, and D, where we know very well that at the end of the chapter, you have the answers for these exercises. Again, at the end of this book, of this chapter, the PDF file, you will find the answers for these exercises. So one of them, it says, return to the first chapter opening question, as I mentioned earlier in page 75, and answer it again now, and try to explain why you could have answered in a wrong way at the beginning. So you go through this question, all right, because you have the answers for them. Now, the weight, which is the force of gravity, and the normal force. I would explain it in, I will do something like some pages of my handwriting, and I will scan it to you guys as a replacement of me writing on the board, because still we don't have writing pads. So I will show you, this needs really an explanation from me for these two kind of forces. One of them is the weight, the other is the normal force, but I can go through them in a brief now to understand what is the weight, what is the normal force. Maybe we all know the weight, which is the force of gravity, which is, you can say F sub G, which is the force of gravity, is equal mg. All right, and G we all know it's 9.8 meter per second square. Great. Now, when we place an object on a table, what is happening? Basically, there is already force of gravity of that object, which is always downward, always downward. As a reaction, there is a force exerted by the table itself or the surface on that body. And that force is it's a force related with the surface. And it's always perpendicular to the surface, no matter what. No matter if the surface is horizontal or inclined, the Fn, which is the normal force, which is a reaction force to an object placed on a surface. Again, the normal force is a reaction force for any object sitting on a surface, and it's always perpendicular to that surface. But we have to understand one thing, that weight and normal force are not action and reaction pairs. It's not action and reaction pairs. Again, I will explain that once I will have the access to explain it to you, either by writing pad or a scanned copy of my handwriting. But now, for now, we know that if you place an object on a table or any surface, there is always reaction of having this object on the table, and this is the normal force. Just to explain to you that it's always perpendicular, I want to go now quickly to the end of the chapter, not end, like a little bit further here, later, further, further. I want to go to the inclined plane, further. Yeah, so I was right to say the end of the chapter. Okay, further, oh come on. There we go. This is an inclined plane. This is a very good example for that. Even if we have inclined plane, you see the direction of FG. FG, no matter what, it's always downward without any angle. Like it's always downward, straight downward. And if you see the Fn, okay, this is the Fn. It's perpendicular to the surface. You see? If you bring a ruler, literally, and you see this line here, it's perpendicular to the surface. And this one is not perpendicular, but it's downward. If I come out from this lecture, having everybody understanding that FG is always downward, no matter what, like I cannot say that FG will be in this direction. No, it's wrong. FG is downward, but Fn is perpendicular to the surface. And that's it. That's it. We have to keep these two things in mind. Now the record will finish because the maximum that it can record is 15 minutes. See you in other record, inshallah. Take care.